Today, we are ready with our first course on water supply engineering. Now, you all might have read water supply engineering during your BTech or MTech if you are an MTech student. But how this course is going to be different from all those courses that you have pursued before is that this time the course will consist of practical aspects of the industry, the practices that we adopt while designing a water supply engineering project in India. So if you know that before joining your job, that will be very useful for you. Now, who can view this course or who is this course meant for? This is meant for BTech students who want to pursue a career in water supply engineering. Second, this course is also meant for people who are currently enrolled in MTech in water resource engineering, environmental engineering, or maybe hydraulics engineering up to some extent. Then the third category which can benefit from this course is the young professionals, or to better way to call them as freshers in some companies, and who are clueless on what to do, what not to do. So these three people can watch this course. Anybody who is watching this course, so to get some advantages on their competitive examinations and government examinations, can also watch, but the number of questions that we will be doing will be lesser than what is expected, so you have to do a lot of self practice. Okay, so without wasting much time, let's start. So when you tell a layman that I am a water resource engineer, what they understand is, what is engineering in water resource? A plumber can send water in my home, but they don't understand that the water supply itself is in a very complex process. And to understand the complexities involved in it, let's take a deeper dive. So we will first talk about the course contents, that why we need to have a course on water supply engineering, because we know that it is a very vast subject, so we need to subdivide it into further various smaller constituents. And the first thing is water demand, sources of water, water quality aspects, raw water treatment, and distribution system. We will talk about each one of these separately. Now, coming to water demand, if you are going to design a water supply system for a city, the first thing that you need is what is its water demand. Okay, so we need to calculate the water demand for a population that needs to be served either today or in the future. Then comes the sources of water. Once you have decided how much water you need, then you also need to know where will the water come from. Then once you are done with your water sources, then you need to check whether the water that you have chosen from a source is good for use or not. So if it is having some problems, you need to provide some treatment facilities. Okay, so first you need to analyze the water quality aspects, and accordingly you need to give it some treatment. Now, what are the various kind of treatments in groundwater, surface water, that we will see. Then comes the distribution system. Once we have treated, we have stored the water, we need to distribute it. So anyone who wants to note this down can pause the video and note it down. Now, we will be providing various course contents along this course. So you need to log on to www.theunceasingsource.com, and in the courses tab, you will see this water supply engineering course. From there, you can get all the details on what to do next, or you can simply send a ping on Telegram at the given location. Okay, so suppose this is a city and you need to design the water supply system for the city. So what is the preliminary data, the most basic data that you will need to design the water supply of the city? The answer is, we need the population, because the one who is going to use that water is the population available there. Now, another question will be, let's say today 1,000 people are staying in this location. So do we need a number which is of the present, of the past, or of the future? Then the answer is obviously of the future, because we don't design water supply systems for a population that is increasing every day. So we design a water supply system generally for 30 years according to the CPHEO. Now, one point I would like to mention is you can download the copy of Water Supply Engineering Manual from the Central Public Health and Environmental Engineering Organization CPHEO website, because all the things, all the standards that we use for designing it are given in that. I will also tell you about the various softwares and literature, but I think this course itself will be enough. For software courses, we will be assigning you something else. Okay, so the preliminary data that you need to design this city for water supply is population. So population of today or future. So future. Now, one thing that I would like to ask you, that let's say I am saying that we are going to design the water supply system for 30 years. Okay, so let's say today we are in 2021. Okay, and we start the project today. When I say start, I am like, you are going to collect data, the population data and all those data. So what will be your design period? Design period is something like, if I say that I have designed this particular thing for 30 years, so design period will be the end of the 30 years, mean 2000. If today is 2021, then the design period will be 2051. Now, my question is, and this is an important thing where people in consulting companies make a mistake. If you are starting to design a water supply system today on paper, then to actually get that scheme completed, it will take minimum 3 to 5 years. Okay, so to take an optimistic side in India, let's say we complete it in 3 years. So you are actually going to start that project in 2024, that is 3 years from now, and consequently and accordingly your target year will be 2054. Okay, so 2024 is your base year, that is when the project will start, and 2054 will be your target year. Okay, in between there is a year called intermediate year. What is the significance of this intermediate year and why it is defined? We will tell you while covering the demand aspects. Okay, so if 2024 is our base year, so 15 years from then, that is 2039, that will be our intermediate year. Okay, so I hope you have got things up till now. Now, moving on, a population for a place keeps on increasing, and the rate at which it will increase depends on what are the various opportunities or the factors available in that area. For example, if there is a place and where industries are coming, lot of job opportunities are going to come, then the rate of migration from rural areas to those areas will be higher. Therefore, the factor from today's population to the future population will be on the higher side. Accordingly, a place which, like Mumbai, so Mumbai, you all know that it's so costly that you just, to afford a bed also, you have to pay a very high amount. So now the growth potential of Mumbai, especially the older Mumbai, is very low, because there is very less chances of expansion, because Mumbai first of all has expanded horizontally, and now it has expanded vertically also, because when you go there you will see a lot of vertical towers, 50-story, 100-story and whatnot. Okay, so there can be various kinds of things. Now, according to the manuals or the books that you have read, we adopt 4 or 5 methods of population projection, the details of which we will study in the next lecture. But for now, we know for certain that a projection is needed in order to anticipate that what will be the future in the target year. Okay, so these are some of the bookish methods that we learned during our BTech or MTech. So arithmetic increase method, geometrical, incremental, logistic, simple graphical and comparative graphical method. Now we all need to have a basic idea of all these methods. But is it something that you adopt in the industry as well? Like, if I am designing a water supply system for a city, is it that I will adopt one method of this or is it something else? Let's find it out. So, before answering that question, the first thing that I would like to tell you is what is population data and where to get it from. So, population data is something, a counting of number of people living in a particular area at a particular time. So, it includes permanent residents, the floating people. There are a lot of things. So, in India, we get this data from census of India. The census is calculated or done every 10 years. So last time it was done in 2011 and now it is due in 2021. Okay, so if you want to find the population of a state, city, district, or a particular area, it is given on the website of census of India. So you can get it from there. The other sources from where you can get the population data is the municipality or the nagarpalika of that area. They also provide you the census data. But sometimes what happens is what the data that they provide and the data on the website has some mismatch. So while you are using it for preparing a project, you need to get it signed from the municipal commissioner or the in charge of that office, so that because we need validation to put anything in the detailed project report or to put any project, we need to have it certified that okay, this data is taken by you and you have certified it. Okay, then some other departments also, example urban development and water supply departments of various state also keep the population data, so this can be taken from there also. But by far and by most, the census website is the most trusted one unless the client tells you to do something otherwise. Okay, now the forecast can be done with various methods. We will discuss it one by one. Now, based on the methods that we have discussed in the last slide, we have prepared an Excel sheet. When you will go into a company, you will be given an Excel sheet, or you can prepare one from your own. But it is better to take an Excel sheet that has already been prepared and has been checked extensively. So, if you are interested in getting any Excel sheet, you can visit our website or you can tell it in the comment section so that we can help you accordingly. Okay, so in what happens in that Excel sheet is that various formulas are given for various methods. So once you enter the population data for one more thing that I would like to tell to that, to project the population data, we need the population for minimum 3 census, 3 decades population, because to interpolate something we need at least 3 values. Okay, so minimum 3 years of data is required. So once you put that data in that Excel sheet, that will give you the projected population from various methods for various years or whatever is your target year. Now once you have got that, a general practice is that we take the average of the 4 or 5 methods that we have calculated our results from. This is a practice that has been used extensively in many projects. The other methods that we use is, suppose there is a town nearby Delhi, and there are chances that it will also develop like Delhi once the area of Delhi is saturated. So we can assume that the growth factor of those places will be same as that of Delhi that has been developed in the past. So in such cases we take something called as a growth factor. Let's say that in 2001 the population of Delhi was 1 crore and in 2011 its population was 2 crores. So the growth factor is 2. Now the place which we are designing for, we can also take a growth factor of 2 or nearby. Okay. Then there are some special methods for special area. For example, when I was working, I designed a project for the Statue of Unity. This is located in a place called Kevadia, Gujarat. Kevadia originally was a kind of village which was not that much developed. So what happens is when you take the census population of the previous year, then if you project something on that population, then the overall result that will come for a future will be very less. Suppose if the population in 2001 was, let's say, 1000, then in population in 2011 was 10,000. 10,000 is actually a big number. Let's say 2000. then in population in 2021 was, let's say, 3000. Okay, so what we are seeing is that there is some increase in the population. Now we need to project the population for 2031. So if we interpolate by this method, the population will be somewhere around 5000 to 6000. But what happens is, since it has been developed extensively for various tourist spots, the Statue of Unity, the various butterfly gardens, jungle safari, and whatnot, so these methods will not be sufficient. So there we adopted special methods, and this special method has also been adopted in Taj Mahal and other places where there is a lot of footfall because of some special thing. And there are a lot of things associated with it, that what will be its demand, what kind of sewage it will generate, a lot of things are there. So we can we can learn about it in a special lecture that will be named as special methods of population projection. Again, the next thing is growth factor. Growth factor is something like, there's a city. So let's say, again, takes the example of Delhi. So in Delhi, let's say the central Delhi, that will be densely populated. So the opportunity of growth in central Delhi is very less. Again, if we go into a little bit of outskirts, so we can see that there may be places available for expansion. So there the growth potential is higher. So we can take a weighted growth factor for each area. Okay, this is something like, rather than taking a same growth factor for the whole area, we can take distributed growth factors. Okay, so we do this in our various projects. So what we will be doing in this project is, I will be telling you about a sample water supply project, and if you all are interested, then a sewer system project also, and I will try to tell you about various things that we need to know and how do we do it. So we will be basically preparing a detailed project report. Okay, so that's the end of it. If you like this video, please like, share and subscribe. Thanks for watching. Have a nice day.